Good morning and good afternoon for all those coming in. I'm very excited to have you guys here for episode 4. Since we started the series 4 weeks ago, we've got to meet with a couple different people. And in case you guys aren't aware yet, Dr. Elvira Rakova, who will be presenting with me today, as she's having a couple technical difficulties, so she'll be here shortly. So I'm going to take advantage of this time to actually give you a background on where she comes from and why I'm really excited to actually speak with her today. She normally highlights a lot of other people's works, which is amazing, and she's extremely humble and will never do any of this herself. So her being here maybe is a little bit of a benefit to me, so I can speak on that a little bit. So she has her PhD in compressed air. That always shocks me because who does that? There's only a handful of universities in the world that actually have that, now that I'm learning more about it. But not only did she get her PhD in compressed air, she also still is active at the university. So she's teaching the future engineers that will be coming into work soon on compressed air. She's also worked in it as she was getting her PhD for 13 years of field experience, and some of those years being in auditing. So she would audit manufacturing companies that we see in order to do this. So that paired with her research and her background knowledge, I think is a very unique experience that we don't really see that often. So she is on her way now, but in this episode, I really want to cover how we can, from her perspective, get the attention of executives. So we've actually had some messages since we started this in the past 4 weeks that there were people who see what we're doing and what we're talking about, and they see that they have these issues in their plants, and they just don't know how to take it to the next level or how to take it to management. So normally you need justification, right? You can't just go in and say, hey, I have this great idea and it's going to do this. We need numbers, we need data, we need backup in order to get something like that approved, to make these big justifications in order to make these types of changes.
Sorry, it's my computer doesn't work today. Well, I would like to speak, always need to learn how to improvise, right?
Yes.
So today I would like to talk about the perspectives on how we, in general, not just perspective on the compressed air, but perspective themselves. So very often, and how people see that we perceive things in a negative way, right? So we are all realists, and when we speak about the energy consumption and when we speak about any other sustainability projects, we always have this idea that it's a burden for us, that it's very complicated, and that we need to sacrifice this. And I actually have brought today, well, we don't do it so technical, but today I'm sending now Danny a presentation. So if you can share the screen, please, through WhatsApp, so improvising. And the problem is that we always see things through the negative perspective. And I would like to share with you just a few things that I learned while being the auditor in compressed air systems, and how, because I spoke recently with a few energy managers, and they always told me that, and also people from the facilities, we really like to optimize our systems, but we don't know how to convince our management. So we always want to optimize, but we don't know how to convince our managers. And this is a moment where I think it's extremely important to think about another perspective. So let's see if it works. So then you got the link. So you can share now. And I don't know how many people, because of we have in the chat because of our technical problems today, but let's just improvise a little bit. And if you can answer, please type an answer below. If not, but just think. But this is a very interesting exercise that a friend of mine gave me, and it comes actually from the behavioral practice and behavioral science. And as humans, we are always tend to see negative or very realistic things. And I want to show you now, once we manage to share our wonderful presentation. So Danny, how is it going?
It's going.
Perfect. I'll share with you just a few slides, few pictures, and then you just write notice for yourself. You see, we're doing a little bit of intrigue here for you. So just notice for yourself what you see there. And maybe this input will help after today a little bit to change your perspective on the system itself.
I'm loading. It's doing the circle. So close.
Oh, no, there is a link.
I have
Maybe
it. It's uploading into StreamYard. Yes. Here we go.
StreamYard is okay, perfect. Amazing. Go to the next slide.
Perfect.
What do you see? Everyone ready? Next slide. What do you see here? Don't tell, just think about it. What do you see here? Then if no one will reply, then you have to play this game with me. So notice.
The link, someone needs to help me because this is a lot already this morning. Maybe this was whole part of this process. I see someone about to finish a puzzle.
Great. Next slide. What do you see here?
A little kid. If I put my son in here, he's looking at me like, Mom, can I eat the rest of this? And I have all of it.
Great. Next one. Anyone who wants to comment on that? So what do you see here? Just want to see the perspective because, for example, I can tell you what I saw first in the messages when I saw it before. So when I saw the puzzle, I was like, it's annoying. There is one puzzle to it. Just why it's not perfect yet there. And then when I saw the kit, I thought, oh my God, this face has to be washed because otherwise you can make the clothes dirty. But I think it's very engineering perspective also. And what you see here on the Apple one.
Oh, I don't know if I want to eat this apple. It's very confusing.
It is like a rotten apple. Perfect. So okay, the thing is that
you have some comments coming.
Oh, really?
So this is the wonder of eating chocolate. Progress, I guess.
Oh, that's nice.
So thank you for helping me because
yes. So I saw here really like a rotten apple. The thing is that when my friend gave me the success, I said this is rotten, it's not finished. But can you go back again to the beginning of this, to the puzzle? So to the puzzle. So here, for example, what I couldn't see myself, and maybe some also in our audience, is that it's very good because it's almost finished puzzle. It's just one piece, right? As you said, just put it there and it's ready. So it has so instead of negative messages, I put a positive message here. It has to be positive. And if you go to the next one, so here there is actually a very cute little baby with the beautiful eyes and with the beautiful hairs and enjoying life, having the best time of life. You said the son will eat everything in this, but this is like the kid is just enjoying and being happy about it, and it's also positive, right? And then you go in the third one. So the third one, if you're not afraid of, you actually can have it, cut it in half and still eat it. There is still half of a good apple. And when I had to do this exercise, I was like, oh my God, this is actually crazy. I see everything from the negative perspective. It's not negative for me, it's a realistic perspective. But then I saw exactly about this thing about what I do as an engineer and what other engineers have to face, energy managers, every time with compressed air system. And now let's go to the next slides and actually let's see what we see there. And the thing is that exactly what I said before. So we focus on the flaws always because it's a simply survival instinct, right? We need to focus on the bad things. Otherwise, like the tiger or I don't know, bear or someone will catch us and will eat us. So we always need to be alert and focus on the flaws rather on the potential. And then I thought, maybe this is actually the message when we communicate to our directors, to the decision makers in the facility, not to show the flaws that our systems have, but shows that sustainability, energy efficiency, reducing the cost, it's actually a huge potential. Because if we go to the next slide, we go now to finally to the point about the compressed air system. Go to the next one and let's see what I saw in one of my last audits. So you have no idea what is this. Somewhere there are components with a run on compressed air. So I had to climb down. It's a production, say it's aluminum production, so very big plant. And there are the things that like super, you don't understand what's happening there. You go there, things like stink. It was cold. Sometimes it's hot. So you don't understand. It's something that you see that you don't want to touch. It's something very negative. You don't perceive as a positive thing. And if you go to the next slide, it was by the way they filter here. So what do you see here? Here is a misuse of compressed air. Here the air was just blowing, like it was an amazing engineering system done by like switching this red, I don't know how to say red thing. The open pipe was blowing about half a meter away. So on the pressure that you don't know even what is happening. So what then resulted in a huge actually peak of the consumption. This peak, and this was used for removing the fog. So it was very foggy in the morning in this facility because it's half outside, and it was just like removing fog. So operators use compressed air for this. And you don't want to probably touch it and mess it up with this system when you see it. And let's go to the next one. So what do you see here? Pressure regulator and pressure with a manometer, right? So here is a little bit, it was not even broken, but it was showing the huge pressure drop every time the machine would start. And it was like 4 bar or 50 psi, while the system was the 80 psi. So it's something that when you go to the first slide, and I don't have to go now, but when you remember the first slide, you're like, I don't want to look where the pressure drop was there. I just want the thing work. That's it. I just want that the output works the same. So, but if we go again to the next one, and we have really few things to say here, I would say it's a huge energy bill. We see poor accountant. When you see these messy, dirty systems, and they're not dirty, of course, in all facilities. This is what I just wanted to show an extreme case of one of the plant. It's not because of the plant, because type of production. Whenever you go to steel manufacturing, steel mill, or any aluminium, for example, or petrochemical, it's not going to be pretty, right? Usually like outside, or conditions are quite harsh. There is a lot of dust. But then at the end, in order the system to run, and it's essential, compressed air is the veins of the plant. In many plants, take it automotive, take it food and beverage, you switch off the compressor, there is not going to be any production, right? So it's essential for processes. It's not just think nice to have, but it's essential for processes like light, it's like water. But it's a lot of money, and usually when we combine all these things that operators come up, the new amazing inventions, all the things that we see then in the facilities, we don't want to touch it, but at the end, the bill is gigantic. And then I thought, let's go to the next one. So exactly. And what do you see here? This is the cherry on the cake. What do you see here? So it's me. So you can see that my hairs are a mess. I have here 2 layers beneath my overalls because I had to go around the plant because it's very cold. It was winter, but I didn't want, of course, to mess up everything. So my fingers are freezing here, and it's a lot of dust. And I'm supposed to wear here actually glasses because my eyes were itching after that. So please wear all the time glasses and earplugs when you work with compressed air system. Except the violation of safety, you could see a not happy person that just worked on the floor, industrial floor for 8 hours working around in cold. So can see not very happy engineer. So, but what I want to say that if you actually change the perspective, and this is going to be very personal for me, you see the person who loves what she does, that really at the end of the day enjoyed a lot finding those flaws and finding those imperfections in the system. And we don't have to be afraid, similar to those pictures that I saw about the puzzle, showed about the puzzles and the kids and the apples. Let's try to look at our challenges from the perspective point of view. From the, not even doesn't have to be positive, but from the opportunity point of view. So what you see here, maybe you don't hear an open blowing pipe and you have to be mad at the operator who misusing it. Maybe it's actually an amazing opportunity to give him a ventilator to remove a fog and to reduce $100,000 of the waste per year of the energy consumption. That can be super easy solution. So, and then my final slide is basically where I'm coming now to say is that, let's go to the next one. So is that every single problem can be our opportunity. And the next slide, that we need to focus not only on what works and not try to revolutionize it, because whenever people hear compressed air, they know the people that know what compressed air system is. It's something messy, it's something loud, it's something complex. And a lot of people say, oh, let's do that. No, let's just start. Let's just focus on what already works. Let's reconsider how we can build on it, right? So how we can reduce the consumption there, how we can make the life of operators a little bit easier, better, smoother. So how we can actually gain productivity from the production lines, right? Because once we reduce the energy consumption, our production lines also can move faster. We can make more pieces of that we recover of the product on that. And this is extremely important. So today, I think like our a little bit chaotic webinar, chaotic coffee, but this is what coffee break is about, right? It doesn't have to be perfect. So I just wanted to give a little bit those input and to share with everyone who works in the industry. I know that everyone is like super overwhelmed and so many things to work on, but sometimes when you feel very overwhelmed and stressed, maybe it's nice to shift the focus on the things, how actually we can make it work and how we build on it. And if we go to the next slide and we think about the compressed air systems, we know that we can replace the open pipes, we can clean the dust, and see finally the pressure gauge there. We can repair the leaks. It's the simple things, right? So we can reconsider the design of our system. We can see how we can reduce the energy consumption, because it's actually not so complicated. And this is the beauty of that, because compressed air systems, they are always meant to be reliable and robust, but the design of them was never meant to be the design of the system. It has to consume less energy as possible. So because it's always there and it's essential for processes, any opportunity to reduce the consumption by just reviewing our system, diagnose the system, understand the inefficiencies there, and replace maybe some components, maybe some system, maybe methods. And this is basically what is my message today about. So maybe, we'll find our missing puzzle, and I guess it's on our last slide. This is what I want to say, that also what we do, finding inefficiencies, finding opportunities, and the last slide again. And this is maybe the missing puzzle also for your compressed air system. So understanding it a little bit better, and trying also to bring this message to other people around the facility, to the C-level people, but also to the operators, explaining how it's going to be easier for them to operate the system, right? How for energy managers, their KPIs will be also better, and for procurement and for others. So I think we should work on bringing the message also from the other side, not only from the negative, but also from the positive side, and also from the opportunity.
Amazing. I know we're over, but people can watch recordings later, or if they had to go, so we completely understand. But I just want to touch on, this is not what I expected. It's really not, because even in my intro, if you go back and look, I'm talking about, you've done so many things. You have your PhD in compressed air, all of this stuff, and then you come at me with this perspective, and I seriously learned something from you. And I don't even know if anybody's watching anymore. I learn something from you every time we talk, and you always surprise me. Like this, I was coming in saying, she's going to show some amazing numbers, some amazing this. And I'm like, now that we go through this, I'm sitting here thinking to myself, oh my gosh, that's probably what everybody else was expecting, because everybody's throwing numbers all the time. If you look at all these component suppliers, everyone's throwing big numbers. I can save you this, I can do that. And I think it just adds to the overwhelm of using compressed air to these manufacturers now, or the end users. And they're like, oh my gosh, another thing that has great numbers. I have chills. That was so good.
We will always can go practical and go into the numbers and so on. So we have so many tutorials also on that. It is an opportunity. So what I want to say, you can easily reduce by 30% your energy consumption, not because your system is bad, no, because it was designed based on the best practice that was used 30 years ago, that is still used. Now we have a new standards, we have a new methodologies, and we will be going over and over again, more detailed, more technical things, but also for the message, also for the directors of the facilities who actually pay the bills for that. You are sitting on a lot of money and you actually can optimize and improve your production of your facility. And for sure, you have compressed air. So for sure, if you have a manufacturing plant, it is going to be there. Not because your people and employees work bad, no, because the state of the systems are very old-fashioned. The design of the systems, the standards who never existed. The design that is done, it was done on the standards, not even the standards, just the best practice. We only now work on the ISO standard to create the most efficient compressed air systems. Only now, in 2025. So it will be published, the best case scenario, 2027 probably. And then, so 2030, the system will be state of the art, let's say. But it's not even state of the art. It's just the way on how we approach the design. So it's a lot of potential. It's a lot of opportunities. And don't be afraid of numbers. Don't be afraid of getting into the system. And we always can help. We have an amazing community of specialists also around us. And it's a really big untapped potential.
It really is. Thank you so much. We're 28 minutes, so I'm going to go ahead and wrap it up. But everybody knows how to find us, of course, here on LinkedIn even, or through the website. And we will see everyone next week. Thank you so much again. And Elvira, thank you. That was very unexpected, but I think it was a really important message for everyone, even myself, because it's overwhelming. And Numbers look great, but if you're coming in with the other attitude, someone can easily say, how are you wasting all of this money for so long? And it could easily be turned the other way instead of the opportunities.
And I think this is the message also for energy engineers, plant managers that are trying to convince their bosses also. Yes. This is the thing. Convince is the way as opportunity, not as the waste.
I love it so much. Thank you, everybody. That's it for this week, and we'll see you again later.